They say two circles of centers A and B are inscribed in a right triangle as shown. If AH is 12, BJ is 3, then CK is dash. We are looking for CK. So let CK be Y. And from our theorem, tangent to any circle from external is always equal. So CK and CF, they are equal. And again, I'm going to add some lines, auxiliary lines here. If I join the centers of this circle and this, again, if I'm joining some points, okay. So I've joined some points. So let's add the values. AH, they say is 12. So we have AH 12. YBJ is 3. So the radius of this small circle is 3. If two circles are tangents, like they have common tangents, the distance between, that's the length of the tangent line, is always 2 times the radius, the product of their radius. Assuming the radius of this small circle is r, small r, while the big one, if it's big R. So to find the distance as the tangent, the length of tangent, so I'm saying HJ is just the product 2 times the product of, so I'm saying that HJ now is 2 times the product of their radii, so 12 and 3. So 2 times square root of 36, 66, so it's 12. So I'm saying that HJ and KG, they are the same circle. So here is 12. Here is also 12. Again, remember, AH and FD, they're also 12 because that's the radius. So this is 12. So the next thing is to get this and this. Okay, this is also the radius. This is also 12. Because from here to here is 12. So 12, 12. So the next thing is to get here. And once we know here, we've known here, these two lengths are equal. So using right triangle similarity theorem, every line, every tangent line is perpendicular to the radius. So these two triangle EJB and triangle EHA, the two triangles are similar. So I'm saying that triangle EJB is similar to triangle EHA by right triangle similarity theorem. similarity theorem. So the ratio of the corresponding side must be proportional. Let's call EJ, let's call it X. So here is also X. So we see that since the two triangles are similar, see that X plus 12 over X, that is, this side of the bigger triangle corresponds to this. HE corresponds to JE, must be equal to 12 over 3. This side corresponds to this side. So we have X over X is 1. 12 over 3 is 4. So we have 12 over X equal to 4 minus X over X is 1. 12 over 3 is 4. 4 minus 1 is 3. So remaining 12 over X. Therefore, X is 4. That's 12 over 3. So our X is 4. So X is 4. So with that, the final approach is to use Pythagorean theorem. Therefore, y plus 12 squared, that's this length squared, plus 12, 28 squared must be equal to y plus 16 squared. That's Pythagorean theorem. So 28 squared equals this squared minus this, which is difference of two squares. You get 28 squared. This one goes over to be minus. So this minus this squared minus this squared is now this. I'm using difference of two squared. This minus this is 4 times this plus this is 2y plus 12 plus this is 28. Okay, let's factor. There is 2 here. So we'll bring 2 out. So 4 times 2 is 8. Remaining y plus 14. You get 2 is common in both. So bring out the 2. 2 times 4 is 8. So remaining y plus 14. So finally 20. Okay, 28 squared divided by, so we have 28 squared, which is 28 times 28 over 8 minus 14 is y. 28 squared over 8. 28 squared means 28 times 28 over 8 minus 14 is y. So we have 4 in 28 is 7. 4 in 8 is 2. That's 14, 2 in that. So we have 7 times 2 in that is 14 minus 14. Do you get 4 in 28 is 7. 4 in 8 is 2. 2 in this is 14. So what is common is 14. So 14. 7 minus 1. So the answer is 14 times 6. So the answer is 14 times 6 is 84. So our answer is none of this.